Okay, good evening, and today's session is about stack data structure, its concepts. So, a quick recap of the previous sessions. We saw what is algorithm, its characteristics, introduction to data structures, and the common data structures and its types. And we saw about array, its introduction, and the types of arrays: one-dimensional array, two-dimensional array. We saw about the Java programs with algorithms like simple programs, positive number or not with conditional statements, prime number or not with for loop statements, and 1D array programs like creation, initializing, accessing, and printing elements of 1D arrays using for loop, and sum of elements in arrays using for loop, and array rotation, and the 2D arrays like matrix addition and matrix multiplication. And we saw about the next basic data structure, that is linked list. We saw the limitations which was in array and which is overcome by linked list. And we saw the definition, its representation and example, and types of linked list like singly linked list, its definition, representation, and example, and singly linked list operations and disadvantages, doubly linked list. We saw a Java program which depicts the insertion at the beginning of the single linked list. And we saw about circular linked list, its representation and example. And we saw the continuation of the previous Java program about the single linked list. But here we saw about the insertion at the end of the list. And in the previous class, we saw about arrays versus linked lists with 6 scenarios, and Java program is a continuation of the previous Java program, but here the insertion is after the given node. And we saw just a quick definition of stack. Today's session is on the elaborated version of what we are going to see about stack, its definition, terminologies, representation using arrays, operations using arrays, and representation using linked list, and operation using linked list, and stack application. As I've already mentioned in the previous class, array and linked list are the basic data structure, and stack you can implement either using array or either using linked list. Today we will see about its concept, how we are going to represent using array, and its operations using array, and stack representation using linked list, and its operation using linked list. And finally, the arithmetic conversions, that is its main applications. So stack. So stacks are linear data structure in which elements can be inserted and deleted according to a policy decision. So you can think of a box containing a books of uniform size, and it is kept one top of the other. In a box, we are arranging the books like one book after the other. So when you see the box, you can see only the top book will be visible, and only that book can be removed from the box. And you can place a new book on the top of the box. And you can take the second book only when if you remove the first book. Without removing the first book from the box, you cannot take the second book. And we don't know how many number of books are there inside the box because we can see only the top of the book. This is the same as stack. You can see the top variable and you won't know how many elements are present inside the stack. You can insert and delete only using one way. There is no two way here. Just like the box with the books where you can take only one book at a time, that is a top book, and you can't see how many books are inside the box. Similarly, stack is the data structure where you can insert using the top variable, delete using the top variable. There is no other option there. It's a one way. So the element which is inserted last will be the first one to be removed. Yes, if you remove the top one only, you can see whatever is there below one. but the below ones are all are the first one which is going inside, but you can see only the top, and that only can be removed first. Whatever you insert last can be removed first. Because of this property, it is known as last in, first out. Even though the element is inserted last, but it is the first one to come out. That is why last in, but it comes out first. So first out. You can also think of another example. You have a CD holder where you have so many CDs inside that. And CDs can be inserted from only one end, and it can be strictly removed only the order it is inserted. Suppose I am having a CD holder and I'm inserting CD1, CD2, CD3, CD4, and CD5. CD5 only can be removed first, and the first one, that is CD1, can be removed only at the last, right? So whatever CD I'm inserting at the last can be removed first. So books in the box, CD holder with CDs are real-time example which you can connect with stack data structures. So stacks are linear data structure in which elements can be inserted and deleted according to a policy decision. The element which is inserted last will be the first to be removed. That is why last in, insertion is last in, but it is the first one to come out, first out. So last in, first out, LIFO. So we have certain terminologies which you should know about stack. So it is the top of the stack, push operation, and pop operation. So top of the stack, the end at which the elements are inserted is referred to as the top of the stack. So you're inserting the elements at one end. That end is referred to as the top of the stack. For example, when you open the box, you have only one end, and that end is the top. You don't have the way to insert or delete at the bottom in with respect to stack data structure. Only you can insert at the top. So the end at which the elements are inserted is referred to as the top of the stack. Next, we are going to see push operation. Push is the insertion of elements into a stack is referred to as push operation, and the deletion of elements from a stack is referred to as pop operation. So stack has two basic operation. One is push operation, another one is pop operation. Push operation is the insertion of elements, and pop is the deletion of elements. Now we are going to see the representation of stack using arrays. You can also represent stack using linked list. So we are going to see stack representation using two basic data structure. One is array, another one is linked list. So depending upon the number of elements, that is the size of the stack, and the inherent nature of the problems associated with memory allocation, it can be represented in memory using either arrays or linked list. Yesterday, while we saw the 6 scenarios, we came across the memory part where you can use array, where you can use linked list. So based on that only, we have to decide whether to use array or linked list for stack. If you have a stack of less elements, you can go with array. If you have a stack of many elements, you can go with linked list. Or you have a stack of less elements and you know the number of elements before itself, then you can go with array. If you have a stack and you don't know the number of elements, and the number of elements is going to be huge, then you can go with linked list, because array is a static allocation and linked list is a dynamic allocation. And if you see an array, you can have continuous location only for certain elements. But in linked list, since it is scattered, you can use it for many elements, right? So it is easier for memory allocations. And the drawback in linked list is for pointers, you have to use extra memory. That's it. So now we will consider stack representation using array. So you have an array which is named as stack, and which will accommodate a maximum number of n elements. So n elements can be n is equal to 5, n is equal to 6, anything. So when an array is used to implement this stack, insertion are allowed only at one end. And that one end variable, we always call it as top. So top is like the index in the array I. Yes. So instead of I, we can use here top. Okay. Used to show the subscript of the top element. For example, you have the array implementation. And if I want to insert, so stack using array implementation, this is a stack. Okay. So I have to insert like 5 elements inside the stack. Now what will happen? I have a variable called top. Why I'm having this variable? To hold the top element. If I don't have this variable, then it is like normal array implementation. If I want to implement stack, you should have a top variable and it should be pointing to the last element which is inserted. That is 4. So 4 is the last element which is inserted. First I have inserted 1. First I've inserted A. Second I've inserted B. The third I've inserted C. Finally I've inserted D. So 1, 2, 3, 4 are the subscript and 4 is the top subscript which is holding the element D. So in this, top has the value 5, which is the subscript of the last element inserted. There should be a pointer called top, which is pointing to the subscript of the last element which is inserted. So now I'm inserting a new variable like E, and it is in the subscript 5. So what you have to do? You have to move this top variable to 5. So if an element, it will be inserted at location 5 and top would have the value 5. So next, if I insert another element F and it is inserted in the location 6, this top variable will move to 6. So we should remember that while writing the program for stack push operation, always you have to have a top variable which is pointing to the last element which is inserted. If you don't have this, it is like a normal array implementation. If you're using stack using array implementation, you should have a top variable, a pointer which is pointing to the last element which is inserted. Now we will see the operations using arrays. So you have push operation. An element can be inserted only when there is sufficient place in the stack. Yes. So you know that for array you should have a contiguous memory location. First thing you have to check whether you have memory or not. So before pushing an element, you have to check whether the stack is having the overflow condition. For example, if you see, I have this array size of how much? 1, 2, 3, 4, 5, 6, 7. So 7 is my size. After 7th element is inserted, if I go with 8th element, it can't be inserted. So I have to have a condition in the program to check for overflow. So based on the size of the array, you should check the overflow condition. If the array size is equal to 7, then it is overflow condition. The stack cannot be implemented. The insertion cannot occur. So before pushing an element, the stack is checked for the overflow condition. Okay. The element is inserted only if the insertion would not result in overflow. Yes, only if you have a space in the array, you can implement the top element can be inserted. So how do you know whether the stack is full or not? Based on the top. If top is pointing to the array size, if top variable is equal to the array size, what is the array size? 7. If the top variable is equal to array dot length, what is that? If top is equal to array dot length, then the the stack is overflow. So you can check the operation like that. Next is using the pop operation. So before deleting the element, you have to check whether there is an element inside the stack. So this checking is known as underflow condition. If the stack is empty, there is no way to delete an element. There is no elements to be deleted. So in order to check that, it's like if top is equal to -1. What is -1? It is pointing to some, it is not pointing to any location. So you can give any number which is not the correct memory size. So -1, we don't have any memory number with -1. So you can use that number to indicate that the top is pointing to -1. If in case the top is pointing to any other memory place other than like the correct memory space, so you can tell that number is -1, -2, anything. So if it is pointing like that, then you can tell that the stack does not have any element to be deleted. So it is an underflow condition. So -1 can be returned. Okay. And so this is like for push operation, you have to check the overflow condition. For checking the overflow condition, you have to check with the array size. Here, for checking the underflow condition, it's enough if you check the top is compared with -1, because you don't have any memory with -1 number, right? So you can check like that. So this is using array. So time complexity analysis, if you see the push and the pop operation, it has a constant time complexity of big O of 1. We can have a detailed session of algorithmic analysis. There I will tell you about theta, big O, and omega. All these are used to specify the best, worst, and average time complexity. And also we will have a look on the space complexity. Just for now, you learn that push and pop operation in the stack, it has a constant time complexity, that is big O of 1. Okay. So next we are going to see the representation using linked list. So linked list representation is like, you have a value field and the next address field. So the value fields like A, B, C, D, always in case of, if you see in the case of array, you have the top variable moving on with the subscript. But here, when a stack is implemented using linked list, top holds the address of the first node of the linked list, and new node to be inserted only at the top. So it can be inserted only at the one end. Like you can't insert at the what do you call, in the middle or at the end. So if you insert in the middle or at the end, it's like normal linked list operation. But for stack, only at the top. So it is like insertion at the beginning of the linked list. So insertion at the beginning of the linked list, instead of head, you can use the top variable. So top variable will hold the starting address of the linked list. So here A is the top variable, and it is the last element which has been inserted, right? Yes. Now we will see about the push operation and pop operation using linked list. So if you see the push operation using linked list, and it is like based on the availability of memory in contrast to the array representation. In array, you have to see the memory size, whether it has overflow, underflow condition. But linked list does not have such limitation of the number of nodes. So you can have dynamic allocation for stack. So you need not check for the overflow or underflow like for the push operation. So you can go with pop operation, but in case like if you want for the warning to be displayed, like in case you have unavailability of memory, like it has crossed 4 GB, only 4 GB we have. In that case, for safer side, we can check for a if condition, like if the memory has been over, then you can't have any dynamic allocation. In that case also, scattered memory allocation can't be done. But it's not continuous memory. Or if you in linked list, it is not necessary that you should have continuous memory spaces. So that is an advantage. But actual memory space, if it goes out of control or out of it's not available, then we have to check a condition prior to indicate the user that it has been overflow. In that case, you can use that condition. And pop operation, we have top, element, and temp, three variables. Top is the pointer to the top element of the stack, and it's a pointer. So top is a pointer which is pointing to the top element of the stack. And if you see element is the element that is popped from the stack. So you will have a variable called element, which will hold the deleted variable from the stack. And temp is like storing the value of the top element before popping. So before popping, you can store it in temp, and element will have after popping the element which is popped. Okay. So finally, we will see these are the four applications. Like we have infix to postfix conversion of arithmetic expression, and we have like infix to prefix conversion of arithmetic expression. So before that, what is an infix is, it is a operator which is placed in between the operands. So you know operators are plus, minus, multiplication, division, anything. So operands are like a, b, those are operands, right? So a plus b. In this expression, plus is placed in between A and B. So plus is placed in between A and B. So this is known as infix notation. So the operator is placed in between the operands A plus B. Next is like prefix notation. What is a prefix notation? The operator is placed before the operands, and you can term it as Polish notation because it is after the inventor who a Polish inventor who invented this notation. For example, you can have plus A, plus AB, plus. So the operator is placed before the operands. Okay. So infix means the operator is placed in between the operands A plus B. Prefix means the operator is placed before the operands. Okay. And postfix, or you can call it as reverse Polish notation. So the operator is placed after the operands. For example, AB plus. So the application of stack is you can convert the infix notation. That is, you can convert A plus B into the postfix notation. That is AB plus. You can convert infix notation, that is A plus B, to the prefix notation. What is prefix? Plus AB. You can convert postfix notation, that is AB plus, to infix notation, that is A plus B. You can convert prefix notation, that is plus AB, to infix notation, that is A plus B. So that's all about today's class. I just wanted to give a complete idea of stack and its concept. In the next session, we will have quick discussion on the algorithms and the Java programs, only Java programs of stack. So you can revise this and then come for the class. I've already told you can get this book, Data Structures. Whichever I'm preparing from this book, it's very in simple terms. You can understand easily. If you want, you can access this book for the reference for data structures.